We are going to start the grade 9th chapter, number system. It is the first chapter from the book. See, we have to understand what is the number system. If someone asks about the numbers, what we generally say? We say 1, 2, 3, 4, 5. These are the numbers we generally speak. But now we have to understand what are the types of the numbers, how we can classify these numbers. Like, first of all, we have the set of natural numbers. Before going to this number system, let's observe the number line first. This is our number line, and on the number line we can see that it's a 0 here, and then we have the positive numbers like 1, 2, 3, 4 and so on. Anyone knows the highest number? No. No one knows the highest number because it is not defined. Okay. Anyone knows the lowest number? No, it is not defined. Okay. Now, 0 is the starting point here, 0, 1, 2, 3, 4, and if you move left to the 0, it is minus 1, minus 2, minus 3 and minus 4. Now we'll try to understand the types of the numbers. First of all, we have natural numbers. If we talk about natural numbers, we can simply say the counting numbers. How we start a counting? We say 1, we say 2, 3, 4, like this way we start a counting. So we can say now the counting numbers starting from 1. What we can say? Counting numbers. Counting numbers. Numbers starting from 1. Starting from 1. 1 and it goes on. 1, 2, 3, 4, 5 and so on. This counting number is called the natural numbers. Now, what about the whole number? See, we say that the 0 is having no value, but now observe it like 0 is going to change it. How it is going to change? If we just add 1 0 to the natural numbers. See, numbers starting from 0. Starting from 0. From 0. We say this is the whole number. So how we write whole numbers? We'll write 0, 1, 2, 3, 4 and so on. So now what we realized, the difference between the natural numbers and the whole numbers. In case of the natural numbers, they are the counting numbers starting from 1. Now, if someone asks, if you said starting from 1, is it 1.2 a natural number? No. Why it is not a natural number? Because it is not a counting number. Let's say if we have 50 students in this class or 500 students in this class. So if I start counting, I will never count like 1, 1.2, 1.3, 1.4. No. That is not the way of counting. Whenever we count a proper numbers like 1, 2, 3, 4, 5 and so on. This is the way of counting. That's why the decimals are not the natural numbers. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. These are the natural numbers. Similarly, if we talk about the whole numbers, those numbers starting from 0. See the importance of the 0. The 0 got added and the name changed. It became now whole numbers. Sometimes we get confused in it, like 0 was in the natural number or in the whole number. See how I memorize. You can see this 0 here, WHOLE, this whole. This signifies the 0 we can keep in mind. Like now see this is 0, 1, 2, 3, 4 and so on. So we got the concept of whole numbers and the natural numbers. The decimals are not included. To be very clear, decimals are not included. Now, if we talk about the integers now, you can say we have seen the positive numbers 1, 2, 3, 4, 5. We have also seen the 0. But what about the minus number? This minus 1, minus 2, minus 3. If, see here, positive integers. Positive integers means starting from 1. We can say 1, 2, 3, 4, 5 and so on. This is the positive integers we can say. Now, if we talk about the negative integers, so negative integers means this one, -1, -2, -3, -4, -5 and so on. Then where is the place of 0? So 0 is considered as an integer like everything. Positive, negative and 0 all comes under the integers, including the 0. Integer is what? You can say example like -5, -4, -3, -2, then -1, then 0, then 1, 2, 3, 4, 5 and so on goes on. So this comes under the integers, positive, negative and 0. So I think we are clear about the number system thing. The types of the numbers, that was natural starting from 1. Then we had whole numbers starting from 0. And then we have integers. Integers means both the positive number, negative number and don't forget 0. 0 is also included in the integers. So negative, positive and 0, everything forms a set of integers here. So we can have a look. This is the type of numbers right now. Now we are going to discuss the next type of numbers in the next. Now we are going to see what is a rational number. See, rational number, a number R is called a rational number if it can be written in the form of P by Q, where P and Q are integers and Q cannot be 0. This is the definition. Now let's see the example. What they are saying, the number written in the form of P by Q, it means it can be in fractions. If I say, just for an example, if I say 1 is a rational number or not? Yes, it is a rational number because we can write 1 over 1. If I say 5 over 4, yes, it is a rational number because this is P and this is Q. But if I say, is 2 over 0 a rational number? No, it can't be a rational number because the denominator is 0. So whenever we are writing a rational number, the denominator can never be 0. Okay, because if the denominator becomes 0, the number is not defined. That fraction is not defined. So this is not a rational number. If I say minus 5.2, is it a rational number? Yes, it is a rational number. Why? Because this can be even written as minus 52 over 10. Okay, this is P and this is Q. So if any number that can be shown, that can be expressed in the form of P by Q, if it is simply 1, we can write 1 over 1. If I say, is 5 a rational number? Yes, it is a rational number because I can put a denominator 1. Now it is a fraction, 5 over 1, so it is a rational number. So it will always in the form of P by Q, that P and Q can be integers, it will be integers, but the denominator can't be 0. Okay, now if we talk about the equivalent rational numbers, let's say if I take a rational number as 1 by 2 and we have to find the equivalent rational number, so we are going to multiply the numerator and denominator by 2. If I multiply by 2, this is 1 times 2, this is 2 times 2, so that will be 2 over 4. This is called equivalent rational numbers. Let's say if I multiply it by 3, so if I do 2 times 3 and then I do 4 times 3, so this will be 6 over 12. 1 over 2 and 6 over 12 are equivalent because if I cancel it out, if I cut short it, like 6 1 the 6 and 6 2 the 12. So this is 6 by 12 and this 1 by 2 exactly same. That's why we are calling them equivalent rational numbers. Okay, I think this is clear till here. Whenever, in short, we can say if we are talking about a rational number, it is going to be in fractions. In form of what? In the form of p by q. And the denominator can never be 0. Why it can't be 0? Because it will not be defined if the denominator becomes 0. So, these are the examples of rational numbers. This was not a rational number. Now, then we talked about the equivalent rational numbers. We can just say multiples of them. 1 by 2 and 6 by 12. Even 2 by 4. All these are equivalent rational numbers. Now we'll discuss the irrational numbers. Now we will understand how to represent a rational number on a number line. See, let us take a number line here. This is a number line. Now, on the number lines, we have the numbers like, let's say 0, 1, 2 and 3. This side, let's say -1, -2 and -3. Now, if I have to just plot this 1 by 2 on the number line, so we know that 1 by 2 is 0.5 and 0.5 lies between what? Between 0 and 1. So we can plot it here like this point, and this is going to be 1 over 2. This is the way we can show our rational numbers on the number line. And this goes on, it continues. This number 3, 4, 5, 6, 7 on, and this also. This is the representation of a rational number on the number line. This 1 by 2, this 1 by 2 is a rational number here in the fraction form.